Can you guys see my screen?
Yes.
Yeah, let me admit it.
All right.
This is my test.
So, good evening, everyone. My name is Brandon Foster, and
Hey,
my
Brian,
presentation
if you
is
if you can put it in slide mode so that we can see it properly. There we go.
the topic of my paper and presentation is cyber forensics in a quantum computing world. So, kind of a standard agenda. I'm gonna go over the problem statement, the motivation, background, related works, my approach, and then data collection, analysis, findings, conclusions, and future works. So a little bit of background. Quantum computing gives us better speeds and stronger capabilities when it comes to doing cyber forensic investigations, due to its higher capacities, for encryption, and as I said, speed. There's a lot of other changes that come with quantum computing. Obviously, one of the big things that has to happen with quantum computing, and especially in the realm of cyber forensics, is we're going to need stricter regulations and protections to ensure that the data and the people are safe across the board. Investigations, whether it be police or it be a business, investigations can be extremely costly, and they need to be as effective as possible to keep spending down to save money for both businesses and forensic investigators, while trying to solve these crimes and other issues. Problem statement, and the reason the problem I was looking at is the importance of quantum computing and how it can affect the investigations, and how applications can possibly be changed and upgraded to assist in these investigations. So cyber forensics is becoming more important in solving cyber crimes and even non-cyber crimes. With the presence and the prevalence of the internet, of IoT, the Internet of Things. I mean, everybody has a device now, or multiple devices now that are connected to Wi-Fi or connected to the internet somehow, whether it be cellular, and whatnot. And so there's more and more places for people to, like evil, or not evil people, but people that are doing wrong, to hide things away. So, can quantum computing increase the capabilities of the investigative programs to make solving crimes faster and more efficient? The motivation for this paper falls in line with the computer and technology. The computer that continues to evolve and has many layers of complex problems that need to be solved. Much of the world is becoming more aware of how their information is being stolen and being used by criminals to commit crimes, which is just a way of saying people are becoming more aware that there's people out there stealing their information and turning around using them to commit fraud or give false information, and all of that is being happened online on the dark web. People's information is being sold back and forth for lots and lots of money. It's a big money industry. For my related works, this is just a table I came up with. It kind of categorized these sources that I was using with kind of the theme of what they were discussing in their paper or article. And then just kind of, I put kind of a synopsis there of what the importance of each of the papers kind of was in that topic. So we had some post quantum cryptography, which is just talking about algorithms and the readiness for businesses and the police and everything alike, um, and what kind of changes are going to have to be made to some of the algorithms that we have. I mean, there's already Shor's and Grover's algorithms, but those are going to continue to evolve as well as the current algorithms that we have for our current state. Um, Forensic admissibility, data governance, regulatory adaptation under the legal and ethical frameworks. So it just gave like um, a synopsis of like how are we going to be able to keep the chain of custody and the chain of command when it comes to doing these investigations in with regular computers and quantum computers at that, but keep the forensic keep it so that it's admissible in court without corrupting or causing any issues with the evidence that they're going through. And then obviously, how are we legally and ethically to keep from letting data get into the wrong hands, especially the data that's being parsed through. And then I went over, industry and technical support, just going over the different tools and applications that are currently available. Quantum forensic methodologies, so the real time, like kind of going over how they're going to acquire how they're going to acquire evidence and the case studies and things like that. And so this is just kind of a little thing I put together. The approach: examine quantum principles, superposition, entanglement, and parallelism. Assess the impact of Shor's and Grover's algorithms on cryptographic integrity. Identify the limitations in classical forensic workflows. Propose quantum-aware logging, timestamping, and data reconstruction techniques. Combine findings into a forensic readiness model. Define the benchmarks for investigators in a quantum-enabled infrastructures. And then again, this is all looking towards, a lot of it was in theory and looking towards the future here. For data collecting, the process of parsing and saving data is, currently that's the computer will go through, and it takes time to go through and search and break down and find the data. But a lot of the parsing and especially saving data, but looking through everything that's found by the computer, by programs like Autopsy or Wireshark, things like that. All the parsing is done by human at this point. So making sure the data is encrypted and tamper-proof when you're saving the data, which with quantum computing, you'll have more capabilities for higher encryption. Right now we have SHA 256. When it comes to quantum computing, we might be able to go to SHA 512 or higher. And I mean, that just makes longer encryption keys for saving data, and being able to keep people out, making it harder for them to break in, or hack and steal that data. And the data is going to be stored, always got to be stored in a way that allows investigators to input chain of custody, chain of command, and preserve the admissibility of the evidence for use in court proceedings. For data analysis, you have tools like I mentioned, Autopsy, Wireshark, and there's many others. And they all have to be kind of used in conjunction with each other, to cover multiple angles of attack, I guess you could say, in an investigation. So, um, you know, Autopsy does one thing, Wireshark does another, um, and there's and so you're using multiple apps, multiple programs to investigate one problem. In the future, could we have an app or a program that does everything, including automation? So, um, can we have a program that combines Autopsy and Wireshark and some of the other programs, and then automates once it's done doing its data process, and you have your file, you have your case, as they use on the Autopsy, like you have your case, you can save the information, but you should be able to open that up and have that application start going through the data, looking for specific keywords. um I mean, my idea is to even be able to have police and investigators have access to the same program, like the same case, because obviously they got to be able to work on the case. Um, but have the cop be able to go in and put pictures in and have the computer scan that picture for, you know, things that may be out of place. Um, it could look for fingerprints. It could look for, you know, things that you might not see with the human eye. Um, and have it all in one place and still be able to keep the chain of command and the admissibility in court. So, for my findings, with quantum computing, you're definitely going to have an acceleration of the evidence processing part of an investigation, just on sheer speed alone. But with the help of AI in quantum computing, you're going to have, um, better abilities to recognize patterns, um, and anomalies that are that you're seeing throughout your investigations, because it'll be able to run off of historical data. So as we know, like AI itself is machine learning, and it'll hold that historical data. So, your applications will be able to see, okay, these are the things that we're seeing, and kind of go from there with the data. Obviously, huge risks going to, um, quantum computing itself, because not only are the investigators and stuff going to have access to quantum computing, but so are the threat actors, so are the hackers and the other people that are trying to, um, do harm to other people. They're going to have access to it as well. So, you're going to have people that are coming up with anti-quantum encryption, or, things like that are meant to delay these investigations, meant to trick these applications that are going to be used into not being able to find what they're looking for. Legally and ethically, compliance wise, NIST, ISO, GDRP, they're all going to have to look at what they currently have. Um, and they do have some pre-quantum compliance and regulations, but they're definitely going to have to upgrade to help keep everyone safe within the, with rules, laws, guidance, frameworks, and that kind of thing. In conclusion, innovation and governance have to go hand in hand. As I've kind of discussed, we might be looking at new applications and faster applications and automated applications, but you've got to have the governance there too. You've got to have the new frameworks. You've got to have new regulations in order for those to keep people safer, while allowing people to enjoy and use the new tools. Quantum computing is going to create massive changes, just on sheer speed, among other things, for the forensic investigators. Again, automation, and all of that. There's lots of changes coming to the digital forensics world. Creating quantum resistance, to help automate the future. And then obviously, as I spoke of, updating NIST, ISO, and GDPR will help build stronger trust from the people and businesses and investigators, and ensure readiness for quantum computers. And as I've talked about throughout my whole presentation here, what are the possibilities? Really, they're endless. Updated frameworks, new applications, and what type of changes for the public are necessary. So what kind of, like, not specifically a lot of us that are in science and technology and computers and cybersecurity and things like that, but what does Joe Public need to know about the changes that are coming? When it comes to quantum computing, when it comes to investigations, how investigations are going to be handled, not necessarily to help them hide stuff, but to keep them safe, to know what the threat actors are looking for, because the threat actors are going to use these are going to use these applications too, because they can take control of someone's computer and run that program, and or create a bug that runs that program on that person's computer and steal data. More in the line of businesses with whaling and spear phishing and that kind of thing. So that was kind of what changes do they need to make as a public. And then these are some of my references that I used. Quite a few pages there. But does anybody have any questions?
Well, for the interest of time, I think your presentation is good. The only thing I can ask is, where do you think the mindset of the public is? As there's a lot of interest in quantum computing at the moment. Where do you think we're going from your research, or in a very short order?
I think that there's a lot of excitement, but I think it's human nature to be excited about something, and then when it gets here, you'll get bored with it real quick, and you're going to find a way to try and make it faster or make it better. So then we'll be on to the next thing. And they'll be trying to figure out how to make quantum computing double quantum computing or whatnot. So
Thank you.
All right. Well, thank you guys very much.
Thank you, Brandon. Thanks.
All right, I think I'm up next. Do you want me to hold off until we're good to go, or just get this going?
Keep
You
going,
should
I
get
think.
going.
Yeah.
Okay, perfect. Just want to double check. So let me share my screen here. Oh man, Teams is not my jam. Man. Okay, so I have to log out and log back in because my privacy settings, so I'll be right back. All right, let's try this again. Holy moly. All right, can we all see that?
Yes.
All right. So first and foremost, I appreciate it. I'm currently deployed right now, so if my internet is whack or I'm in and out, I do apologize in advance. I'm using some jank internet right now. But anyway, okay. So my name is Zukango. Today I'm going to go over presenting my capstone project under securing IoT medical devices through a zero trust framework. So for agenda, I'm going to go through the problem statement, motivation, background research. In the sake of time, we all know the agenda. We can see it right there. So my problem statement, with the rapid expansion of IoT medical devices dramatically being increased within healthcare environments, many of these IoMT devices run outdated firmware. They lack strong authentication. They operate without identity-based segmentation. So that's kind of the main focus why I wanted to pick somebody in this. Medical devices were kind of not known to me, so I wanted to choose something different, kind of expand my knowledge on it. So traditional perimeter security, once sufficient in centralized hospital networks, can no longer protect decentralized or medical devices, which we're going to go more into. As highlighted in recent studies, connected medical devices are often deployed with minimal security controls, showing exploitation for weaknesses to compromise patient safety above all. So my ultimate project seeks to address these vulnerabilities by exploring how zero trust principles can offer stronger protection for those IoMT ecosystems. And you'll hear me say a lot of acronyms, but mainly IoMT, you'll hear a lot. Motivation for this, my motivation for this stems from the growing frequency of the cyber attacks targeting healthcare organizations. Specifically in 2025, one that kind of intrigued me a little was over 1 million of those IoMT devices, were exposed in a major breach, demonstrating how widespread and severe the problem has become. That was the most recent find from there. Regulatory bodies like the FDA, CMS emphasize the need for stronger cybersecurity, but there's really been no growth in guidance and how we can kind of protect those networks and frameworks. So on my side, by developing a zero trust model tailored to our medical environments, this research aims to bridge that gap, provide those institutions with a more practical and adaptive solution. I kind of like to highlight adaptive a lot more because I think in today's world, that's what we need a little bit more of. My research approach, it's grounded in mainly academic literature, industry reports, and I try to have a main focus on governmental frameworks just because of where hospitals and medical networks are. Me being in the military too, I looked a lot in the VA programs, and that is a whole separate can of worms when it comes to security. It builds upon the core principles of zero trust, continuous verification, least privilege access, evaluates how emerging technologies such as blockchain or AI analytics and physical unclonable functions can further strengthen those device identities and monitoring. So my ultimate goal here is to create a healthcare specific zero trust model that supports real world clinical workflows. A little bit of background, I already kind of covered a little bit of it. So IoMT devices share several common vulnerabilities, outdated software. Like I said, I already went over this. Breaches like the 2025 incident revealed that many hospitals lack proper monitoring. Regulatory agencies now encourage continuous monitoring and least privilege access, acknowledging that, however, nothing's really been implemented. As for my related work, I covered several areas from the IoMT security platforms. So research showed the need for adaptive behavior, cloud native access controls, blockchain proposed to ensure device logs, hardware-based PUF authentication, referring mainly to tamper restraint, and then case studies from the VA, like I talked about. While these studies offer valuable insights, none provide a comprehensive healthcare-specific zero trust framework that accounts for these legacy devices. So my approach overview, integrates zero trust principles with findings from academic industry and regulatory sources. The resulting model, called the Zero Trust Framework for Medical IoT, or as I like to call ZTFM, incorporates continuous verification, least privilege access, behavior analytics, new technologies such as blockchain. It's structured around the unique operational regulatory needs of healthcare environments from the studies I found. So breaking these down in a more visual sense, I built it on 3 core layers. The first being the device identity layer that uses hardware-rooted identities, particularly PUFs, to authenticate devices. This also prevents impersonation attacks, ensures trust starts at the hardware level. Then we go to policy and access control that enforces least privilege, role-based access, in that dynamic sense, such as device behavior, location, or even risk level. Then we go into monitoring analytical layer. So I use tools such as machine learning, behavioral analytics, which enable real-time threat detection. And I think that provided continuous verification, which is kind of the core requirement for zero trust. Looking at more security layers, I'm not going to go fully into this one, but the framework integrates things such as IAM and NAC for centralized identity, network access control, machine learning, like I talked about, blockchain infrastructure for audit logs, automated policy verification, and a really heavy source under regulatory alignment, such as like HIPAA, FDA guidelines, CMF frameworks, even the NIST SP frameworks. So this architecture not only strengthens security, but aligns closely with real clinical operations. I think I skipped a slide here. Data collection overview here. Use secondary data only due to the ethical and restrictions. So I didn't really want to focus on those ethics and more just on the core foundations. These included peer-reviewed articles, government documentation. Obviously, no patient data or device logs were used or anything like that. All right, so for my qualitative data side, to analyze these materials, I use the document review, extracting key models, vulnerabilities, recommendations from security platforms. For framework mapping, I evaluated how the ZTFM aligns with those HIPAA and NIST zero trust requirements, and testing a framework case known against breach scenarios. So I used case-based simulations, which was kind of fun, and I actually think that helped a lot with, I don't know, visually seeing how it is incorporated. Those key performance indicators to evaluate the effectiveness, security effectiveness, correctness of identity and access enforcement, scalability, compliance readiness, legacy device support, and monitoring. So ultimately, these indicators help assess whether the framework here is practical and scalable and realistic even. So I can talk the big game, but is it even realistic? All data was securely stored in encrypted cloud storage with MFA. Sources were organized using additional tools. I'm not going to go too far into this one. Let's actually jump to my findings. Here we go. That's where I want to get to, just for sake of time. Across nearly all sources, there was a clear consensus. IOMT devices lack the basic security features such as modern encryption, authentication. Perimeter-based security models are insufficient, as we discussed. The zero trust aligns strongly with healthcare requirements, particularly continuous monitoring. So ZTFM extends current models by incorporating hardware identity, behavior analytics, and blockchain logging. They're not present in most existing other frameworks. Scenario testing, when I tested the frameworks against breach scenarios, PUF authentication eliminated identity spoofing. The least privileged segmentation prevented lateral movement, and the behavioral analytics detected anomalies much earlier than traditional. And blockchain logging protected forensic evidence and improved that compliance standard. So key findings overall, I confirmed that IOMT vulnerabilities are widespread, systemic. Existing framework approaches lack identity-centric controls. Zero Trust provides a strong conceptual foundation, and it fills a gap by offering practical alignment implementation models. So here we go. Sorry, these are not in order. I apologize. All right, so for future work standards, I'd really like to more focus on see as far as future work goes, the real world pilot deployments, exploring AI-driven anonymous trust engine. I know AI is the buzzword for everything now, but for this application, scaling blockchain and PUF techniques in large hospital environments, developing new trust and risk metrics, and working with regulatory bodies to integrate ZTFM into national healthcare standards. Long-term opportunity-wise, this framework could support national healthcare cybersecurity models, enhance telehealth and remote monitoring systems, which in today's world is almost everywhere, predictive threat modeling using AI, once again, and automated readiness systems. So the goal is to create a more secure, resilient healthcare infrastructure nationwide. And I got through that without the internet breaking, so that's a plus. So any questions on this one? And thank you for your attention.
Okay. Thank you, Zuck. I have a question.
Sure.
And I'm not going to ask where you're deployed to because you probably couldn't say anyway.
Right. A really lovely place. It's 2:30 in the morning, so it's fun. So
2:30 in the morning. Okay. See, people will get up in the morning, Rich.
I'm a little hopped up on coffee. I'm not going to lie, but I'm here, you know.
Okay. So in a perfect world, because you've got this done and you'll be back from your deployment, what would a pilot model look like for you? If
I think
you
the
could design.
Yeah, so I think, well, it was kind of fun to experiment with the threat modeling because I got to do basic, I mean, it's very basic. As I put in the YouTube demo, it was very basic kind of script modeling to show that, hey, a certain threat may hit a, certain hardware level. And then instead of just blocking it like we usually see, I guess I like to see in a real world application, trace back, and as far as like how can we learn from this instead of being like, well, there's a threat and we stopped it. I would rather see important data on it. I'd rather see like the logs of it. So I guess I don't know, maybe that's it. I just like to see more of it in real time compared to just being like, well, here's a simple solution, it stopped the threat. I want to see more of it actually being conducted in the right way and seeing the logs for it, because I want to see how it turns out. So
it would be useful if you could get into a small clinic or
Yeah.
something. You're still down in Vancouver when you come back?
Yeah, I'll be down in Vancouver, correct.
Okay, because they may have some small regional clinic down there that you could approach.
Yeah, and
As
it's
a,
good.
you
Yeah,
know.
because from the studies, it's kind of interesting seeing some of the more smaller focused articles. There surprisingly is a lot of those small infrastructures and hospitals and clinics that are affected, which is kind of sad because they pertain to more maybe low income individuals or different healthcare plans. So
You might be able to talk to, when you get back, give me a call because I
Okay.
might have some contacts for you.
yeah,
Okay,
let me write that
thank you.
down. That's good.
Yeah, just a quick question, Zach. Since the implementation of Zero Trust, do you think there's been any improvement in this IoT stuff?
Truthfully, no. I think it's such a, like we keep, like there's articles upon articles upon it, and people keep talking about it, and I'm just very curious on why it's not being implemented. Or if it is implemented, it's like a very like, hey, well, we updated the security patch, and it's kind of like I don't think that's good enough because we're seeing it affect. I guess from my standpoint, especially in the military, you see just I deal with a lot of like, especially back in recruiting, you deal with a lot of PII, a lot of socials and people's bank info and everything. And I think a lot of people forget about the medical side of the house that incorporates even more data. And I just don't know why there's a greater sense on one other than the other, if that makes sense. So it's not frustrating by any means, but it's more just I kind of am missing the why factor and why one isn't being one is not greater than the other, I guess. If that makes sense.
Roger. Thank you. Harrison is still unable to speak because of his mic. So let's keep going. Any other question for Zach?
Awesome. Well, I really appreciate it, everybody. I do.
Thank you, and be safe over there.
Thanks, sir.
Yeah, thank you. Be safe.
Thank you. I
We'll see
appreciate
you
it.
when you get back.
Oh, yeah.
Brandon, you up?
Alrighty, can everyone hear me?
Brandon, so yeah, we can hear you.
Yep.
Okay.
Yes, we can,
Ooh,
Brady.
this is a little funky. I don't know if I've ever, let's see, hopefully. Here we go. Okay. Can we see my screen?
Yes.
Awesome. Alrighty, let's get started. So I am going to go over the agent that I built. It's a model context protocol security agent. It's for the masters, as you all know, of cybersecurity. Okay, and here's my agenda today. I'll be digging into the problem statement, why I thought this was a good agent to build, and then kind of the motivation and the background of what this is stemming from, why more or less I chose this topic specifically. I'll be digging into the approach, so the 3-layer architecture and the design matrix that I put together to actively mitigate these exposures. I actually will show a demo of the agent today at the very end. So you'll see that, and I'll detail exactly how it works. So we'll talk a little bit about that. We'll dig into the data that I collected to mitigate these types of exposures, and then how we're going to analyze that data. And then we'll go over the findings, and then we'll close with conclusion and recommendations and future work. That's the idea. So the problem statement is pretty simple, right? As we all know, more and more people are using AI. And what an MCP server does, it allows for AI, so large language models, to connect with like personal data. So stuff like your Instagram or your calendar or your email. And so that adds a whole new level of risk exposure that now an MCP server, if any sort of malicious data is inserted into, these LLMs will give you're at more higher risk of losing your data essentially to what's called zero-click attacks. And so what a zero-click attack is essentially, I could insert a malicious prompt into a PDF, and the agent, if you're not monitoring the agent, it'll just return malicious credentials back to the black hat is the idea. And so really what I built was to really sanitize all inputs that come through an MCP. So that way there's a less likely, we're mitigating that risk essentially. So my motivation for this specifically was actually based off some of the readings that I had in throughout the program. So I don't know if you guys are aware or not, but there's a botnet called Asuru that recently attacked a web-based form called the Krebs Insecurity Form with 29.6 terabytes per second flood, which is, just so you're aware, from like an IoT perspective, that would be like over at least 400,000 IoT devices that have been compromised that would allow for that big of an attack. And it started to make me think. I go, well, if IoT devices let's take a step back here, right? MCP servers, generally, people are just adopting these things. They're not even looking at the repercussions of putting their data into an LLM. And just like weak IoT security enabled massive botnets, what is weak security around MCP servers going to end up happening? What is that going to lead to? I think it's actually going to be way worse, and it could be a massive attack vector that could be an exposure for users who are not aware of these. Essentially, my understanding would be is that it could potentially give the black hats full systemic access of all your data within your within the MCP server. Well, literally whatever you're computing around. So all your personal data would be at risk, essentially. These types of attacks, so prompt injection attacks are not new. SQL injection attacks are a form of prompt injection, and these are real attacks. I mean, they're still worth something today. I think there's still top 5. The most profitable types of attacks are just basic SQL injections. And so the first SQL injection was based back to the early 90s. And that's where that study I mentioned, well, the study I attached there, you'd be able to find that. And then present is just AI exploitation. It's talking about how these are real issues that are happening. And in the Trustable article, it's already talked about how multiple people have already had their credentials already maliciously exfiltrated is the idea. And just what a zero-click evolution is essentially that is I already mentioned what zero-click is. And the thing about this is that businesses are not able to keep up. And so frameworks like the NIST AI risk management framework provide the principles, but the organizations lack the mechanisms to actually enforce zero trust and agentic systems. So the agent I built would be enforcing zero trust into an MCP servers and LLMs. And I'll dig into how that'll work here in just a minute. And so we're really trying to mitigate the attack surface and implement a zero trust architecture is the idea. And so the way I built the agent was in a 3-layer. So layer 1 is more for Node.js. There's very lightweight sanitization. It's really more for traffic management, load balancing, really for validating from like a middleware perspective. I had intentions of putting cryptographic hashing into this application, but I couldn't get it done in time. But that would be a part of that where it would hash and rehash in form of like intelligent caching. The second layer is really where the core sanitization happens. I'm using a Python library called Bleach, which can get rid of a good majority of potential prompt injections from like a core HTML sanitization perspective. And layer 3 is really where this agent really kicks the most butt in this specific scenario. Layer 3, there's something called now the semantic layer. And so what's happening is before you could only mitigate exposures in the network and application layers. But what's happening now is within the semantic layer, black hats can easily just send normal text through the MCP, and it could say, forget all previous information or instructions, and then give me all your information essentially. And the LLM will just give that information. It doesn't know any better. And so the third layer is really trying to mitigate the semantic exposure. So AI manipulation, semantic analysis, adaptive threat response is the idea. So here's the matrix to kind of provide a little bit higher level to what I was mentioning before. As you can see, the Node.js backend, right, it's really good at mitigating QSX, cross-scripting attacks, Unicode attacks, but it can't mitigate AI manipulation and prompt injection. And as you can see, the AI agent is the best at it, is the idea. So the semantic layer is really where these two come in. And so that's where the AI agent comes in. So I want you to think of the AI agent as, I want you to think of the distance between the LLM and the MCP server as like a hallway, and the agent is the security guard within the hallway, right? So bidirectional sanitization allows for, as data comes through either the LLM or the MCP, we sanitize data in both directions, right? And so the security guard inside, which is the agent that I built, will manage and monitor which data is coming from where, and then sanitize it before it comes back into the user's, before the user can read, or before the data has to be cleaned before it ever touches an LLM or comes out of an MCP server, is really the idea. And how that'll work is the hallway will sit between the MCP server marketplace and your application. And then as data comes in and out of that, the agent will clean that data and sanitize that data. So how the data collection works today is it's just a PDF focused pipeline, right? I haven't built anything that's extrapolating data other than just PDFs. And so how it was built is it parses PDF content, it applies the sanitization layers, it converts it into JSON, and then it validates the output, is the idea. And then looking at data analysis, it's a 3-layer routine, like I mentioned. It's going to sanitize it, and then it's going to turn it into functional JSON. So what's cool about this is all this is happening. So the collection and the analysis are all happening in one API call. And so it saves a lot of time and can mitigate a lot of exposures and makes it really easy for the agent to implement and collect and analyze which data hasn't been sanitized and needs to be sanitized. And so I ran my findings, so I actually created 30 malicious PDFs. And I'm going to actually show them here. It looks like we're running out of time. It said I only have 5 minutes left. And so I was able to mitigate every single one of those attack surfaces on all 30 PDFs and create JSON, 100% conversion of JSON. One of the core findings, if you can see in the figure of the chart, so this is based off the 30 PDFs that I scraped. I actually thought the average sanitization time would be spent more in Node, and I was actually blown away that the majority of it was in Python. And so that was something, if you want to learn more about the specifics of the layer breakdowns, you can see right below the figure that I have there that the Python and AI agent layer breakdowns within the Python backend and the Python agent. Text extraction is performing in a little bit less than a second, so 800 milliseconds, and then you got your agent sanitization, which is 110 milliseconds, and then your AI enhancement at 2630 milliseconds. So some other core findings. So based off that, that the Node.js PDF parse library was built to originally parse all the PDF data. And so yet the logs that I have actually show that the Python backend is actually performing the text extraction. And so I'd have to dig into that. Another finding I had, I dug into, is that this pipeline cannot, so there's a malware exposure for this. So if there's any malware attached to the PDF, it could potentially break the sanitization agent. And so I would need to build an upstream sandbox to make sure that malware was scrubbed out, is the idea, before running it through the pipeline. And then, conclusion from the 30 PDF test, this agent is proactively, it did a great job, right? It proactively mitigates prompt injection risks before they ever enter agentic workflows. So the effective threat neutralization was 100% in success. The JSON conversion, everything worked 100%. The PDF parse is something that I would dig back into. I already dug into that. And then one core thing about this study, it was 30 PDFs that were 5 pages or fewer. And so if I wanted to run this again on larger file types, I would have to run a new study, is the idea. So my recommendations would be to go back and validate the architecture, dig back into the Node.js and the Python backends, and essentially confirm if PDF parse even needs to be used, and then optimize Node.js based off what happens with PDF parse in that library. Future work, I mentioned before, I would like to implement trust tokens, human alert, loop alerts, and then document sharding and adaptive models. Those are some of my key references, and that's it. Does anyone have any questions? So I'd be happy to show the application if you'd like. If not, we can just do Q&A. I'll let the team decide, or I'll let the Dr. O first decide.
Well, Harrison is still unable to talk, and if you can quickly run it if you.
Sure.
It would be nice to see the application.
Yeah.
Cool. So everyone can see this, correct? We're
Yes.
looking at it?
Yes.
Awesome. So I don't need to put an API key in today just because I have everything locally set up through my .env file. But so we have let's see. So I actually have a bunch of PDFs. I'm actually going to show you this PDF first so you can see what's on it before I sanitize it. Okay. So this PDF, right, it has some test characters. You're going to see some invisible characters, symbols and special characters, Unicode text, mathematical symbols, yada, yada, yada. As you can see here, right, this is riddled with potential threat exposures. We'll actually run this document through the pipeline. It's going to go ahead and validate the text. It's going to extract the text, and then it's going to perform AI sanitization. It's then going to kick back a nested JSON object with all those potential risk exposures wiped clean, and then a breakdown of this data and what it recommends. And so now I could say, can you return the JSON object that from this PDF? And then it's going to kick back this JSON object. And then the goal, and I haven't set this up yet, but there'll be an access to MCP marketplace, which will kick into this MCP marketplace. And then it'll just send this clean data through that MCP marketplace is the idea. And then anytime it comes back, it'll also monitor as well. This doesn't have to be showcased within the UI. This could also be run in the terminal, but for demo purposes, I thought it couldn't hurt to showcase the UI.
Excellent demonstration. Morgan? Anybody else has any question?
I've spent a lot of time on that project. I don't think you have any clue.
Braden, we can definitely tell just with your thoroughness.
I've spent a lot of time.
I have
Thank
an
you.
idea of how much time you spent.
I've been busy.
Yep, good job.
Thank you. So does anyone have any questions about the MCP exposures at all? I would love to elaborate. I've learned a lot. I thought the semantic layer was really cool. I think that was probably like I built this thing and I didn't realize that it was built to also mitigate the semantic layer. And so if you guys want to learn more about prompt injection attacks, I think the semantic layer is very interesting. I mean, it's really simple. And it can trick LLMs very easily. And I think it's something that for me specifically, I'd say the most important thing that I learned from this project and the coolest thing that I learned was the mitigation of the semantic layer and what the agent could do.
So how far are you willing to take the project or the research?
Oh man, I actually think I don't want to look at it ever again once I'm done. But maybe I'll feel better about it in a couple weeks, but I need to take a couple weeks off from the project.
Wait a second.
So
I was listening to this and wait a second. I was listening to this and wondering where you could take this next. After you get your second wind, what are some of the
yeah.
applications that you see, the markets that could be used for this?
Well, I would like to actually
Yes.
build the marketplace. So instead of using an outside resource of marketplace, I would put together all the APIs and then I would build that marketplace. That would be what I would like to do, just to make sure that the sanitization model works to the standards that because I would have to test it all, right? And make sure each API is working through the agent. But I think we could make do with using a marketplace for the time being, but that would be the next big step. And then ultimately also getting those trust tokens put together. So the the hashing and the rehashing, so we can do intelligent caching. So you don't have to re-sanitize PDFs that have already been sanitized, right? We don't want to that just would take a lot of computing power that is unnecessary. And so those would be the two main things. But I currently work for a software consultancy and they want me to meet with the COO about this and they're all excited about it. And so
That's exciting.
That's very
can-
exciting.
Sell it and
That's
retire
good.
early.
no, I don't think
No,
that's
he's not
how it
gonna
works.
retire.
But I'm
Now,
not
not if he's
retiring.
already
But
working for them, but this has got a really practical model. And there's a business component to this and a marketing component. And you're still down in California, aren't you?
yeah. I still live in the Marin area. We're actually moving
Yeah.
pretty soon here, hopefully.
Moving to where?
Well, we want to move further north where I live now than where I live now. But that's a different
Oh,
conversation. I
you're
think
not
maybe
coming to
TMI for this
Washington.
call.
Okay, you're
No,
not
no,
coming to Washington. Okay.
not
but
that
the-
north.
Need a boat.
Okay. But yeah, you need a canoe right now. Now I know why they live down the rivers here. But let's talk about this when you get your second win. And the other thing, doing a paper on this, Patrick, let's track him down because this is paper worthy. This is conference worthy.
Definitely.
You know, with the way you got this developed for, you've got a
Yeah.
marketplace here.
Dr. Ofor already told me it's paper worthy when we talked about it a while ago. And so, yeah, maybe
See?
that's something I can work and take offline with him. But yeah, I think I need a few weeks before I dig into that.
You can
just
have
to
a
be
month.
completely honest.
Take till January 30th.
Hey, by the way, Harrison said
You're so
that's a
generous.
great effort. So,
Thank you. Yeah, no, it's too bad he couldn't chime in.
yeah,
But
This was
shout out to
yes.
Zook for good feedback throughout the program, the Scrum boards. I mean, he was a big help too. There was some stuff he chimed in on that was helpful to me, and so takes a village. And
Yeah. I've seen how far all of you have come since the orientation.
there's truth to that.
Yeah. I hope you're
Uh,
patting yourselves on the back.
yeah. The three presentations are fantastic. So, congratulations on your effort. So,
Yeah. Yeah. And poor Harrison has had a terrible day with his computer. It just literally bellied up on him. I mean, he was really stressed. So this came out really well. Thank you all.
yeah.
Now I get to go outside and swim home.
All right.
Bring
Y'all
it,
take
bring a
care.
snorkel.
Take care.
Yeah, bye.
Huh?
Bye.
Bye. Bye.
Yeah.
I stuck my head up into the fucking vault or the attic. It doesn't look like anything up there is leaking. Like, I mean, I can't really tell, and it's barely raining outside, so if I can register it, I don't think. But like, it doesn't look like there were any like recently dried up streams or anything like that running down the ceiling. And I mean, the fucking insulation looks like insulation, so I don't fucking know about that. Like, I can't really, like, unless I go all